Hello everyone, my dear students, not only students, because programming is fun, and of course many people nowadays learn programming. You don't have to be a high school student, college student, university student to learn programming. Anybody. It's very interesting, and I welcome all of you. Today is a new course, so we are going to open a new short course. It's called Object-Oriented Programming with Python. It's going to be short, I think, around maybe 7-8 short lessons. And we are going to explore how object-oriented programming paradigm is applied or implemented in Python. Object-oriented programming is now de facto standard paradigm methodology. Basically, all programming languages now object-oriented, the ideas of object-oriented programming are the same. However, different languages implement them slightly differently. I strongly recommend you also, by the way, if you want to compare how it's done in Python and how it's done in C++, I do have a course on my channel. Also, I think 7 lessons. 7 lessons, please take a look how object-oriented ideas applied in C++. And of course, as usual, I always appreciate your likes and your comments. They help me to promote the channel. What is object-oriented programming in a very short terms? By the way, please, also, if you're watching this course, I assume you watched my previous course, Python Fundamentals. If you don't know Python Fundamentals, it's very hard to proceed with object-oriented Python. So please watch 13 lessons introductory course on my channel. It's called Python Fundamentals. Now, object-oriented paradigm is an attempt to create bigger units than functions and containers. Functions, containers, variables, that's a very powerful tool set. And for many years between OOP, before OOP, we did use just a standard, we call it procedural approach, when the main logical entities programmer operates are containers, variables, and of course functions. OOP is an attempt to get higher, to combine now in one logical unit functions and data. And we call this combination a class. And technically speaking, don't think if you follow OOP rules, if you understand OOP concepts, you are or you immediately become a good programmer. No, of course, it's just a tool, it's just a technique, it's just a framework, and you may create beautiful programs using old approach, procedural approach, or on the other way around, you may create awful, very bad software using OOP. Some languages, by the way, like Java or C#, they enforce OOP, so even for the Hello World program, you have to have a small class. So you have no choice. Everything you do in your program must be object-oriented. Probably this is too much. So I think Python approach is more practical. It's up to you. If you want, you can stick to an old paradigm, procedural programming. You use just functions, containers to achieve your programming goals. If you want, you can use new object-oriented approach, or you may combine. So Python is an easygoing language, and it doesn't enforce us to use, let's say, classic paradigm procedural programming or new paradigm object-oriented programming. Essential terminology. So, as I told you, class is, by the way, you see those terms on my screen. So, class is a combination, a set of related variables. Let me make it larger. So class, it's a combination of variables, functions, and it is created to achieve certain programming tasks. So it's not just loose combination of variables and functions. Yes, they are related and they have certain goal. Because class consists of both data and functions, we call a variable that belongs to a class an instance variable or a property. It's not 100% the same. Later on, I may discuss a subtle difference between them, but for now, it's just a synonym. So instance variable or property, it's a variable, it's a data that is part of your class. Method is a function that belongs to a class. Now, very important step. You work with OOP in two basically stages. First, you define your class. Second, you start instantiating, or you start creating objects, representatives of a class. So that's why object is a representative or an instance of a class. You may think about class as a plan, as a blueprint, as a template, as a guide. But instantiation, it's actually implementation class ideas. So you prepare class, you define data members, you define the functions, and then you start creating real objects, and we call this process instantiation. When you instantiate, when you create an object, there is a special method, and it is automatically called, and we call it constructor or initializer. So It's basically constructor or initializer. It's to give a birth to a brand new object. If it sounds right now a little bit abstract, don't worry. We now going to start practicing, and I hope all the pieces of puzzle will come together. So let's be more practical. Technically speaking, you can think about class as a new type of data, super type oriented to a certain problem, real life problem, or your own type. So let's say in my program, in my software, in my application, I have to handle 2D objects, rectangles, somehow, and I decided to create a type for rectangle. You see, line number 1, I created a class, and you see 3 methods. So my class belongs 3 methods belongs to my class. So this is constructor. This is the first, or just a method. Let's not count. So constructor, method, and another method. So that's a class definition. You see 3 components. You see constructor. By the way, it's always the same name. Be careful. Constructor or initializer name is always 2 underscores, init keyword, and 2 underscores. Pay attention, please. All the methods, they have special parameters. Self is also like a keyword. We are going to talk about self. Right now, it's 3 methods, but where are my instance variables or my properties? Guys, they are defined inside your constructor body. So you can clearly see that my objects, my future objects, remember, rectangle is a class, but later on I will create based on this class object, so they will have 3 properties. Any rectangle, of course, has a width, a height, an outline. It's a character we need to draw rectangle, because we are going to visualize rectangles on a console window. And that's why 3 data members or 3 instance variables or 3 properties, width, height, and outline. Whenever you use properties in a methods, you must use prefix self. So when we start instantiating objects, you will see how it works, but right now just remember all the instance variables require self prefix, and beginners very often keep forgetting about it, and they miss self, and they have compiler error. By the way, I may have in each method of course, local variables. So when we discussed functions, I explained there are so-called local variables inside any functions. They are short-term variables. You, of course, can create them inside any method because method is a function. It's just a special function. So we don't use self for local variables, but we use self keyword for any instant variables. So let me summarize. My new class has 3 methods, including constructor. My new class has 3 instance variables or data members. Init is just to prepare rectangle. Grow is to make it bigger. You see what happens inside grow. I increment both weight and height by 1. And shrink is to decrement rectangle dimensions. But again, it's just a class. It's just a template. It's just an idea. The real programming starts later on when you instantiate class representatives. So what I'm going to do, I'm going to save this as rectangle class. So I create this, I save this in a separate file. I call this file rectangle underscore class.py. But another program or main program going to test, instantiate my rectangles. And you see what I need to do in line 1. I need to connect my class definition to my main program. Line 3 and 4, that's actually instantiation. So you see what happens when you instantiate. So you call constructor, so whenever you use this name of the class, automatically init method is called and 3 parameters saved in the instance variables. So if you look at the coding, you can see 11 going to be saved here in the width, another number going to save here in the height, and the outline character or drawing character going to be saved in the instance variable outline. So that's what constructor does. So constructor has 3 parameters. By the way, it's interesting, but in my definition, I have 4 parameters, but that's a requirement. So all the methods, they have an extra parameter. So when you call them, you don't need 4, you're going to need only 3. And self now, let's talk about self. Self is the address of the current object. So when I create a new rectangle 11, 11 and minus, the memory for my new object is allocated, and this address is actually self. So when the constructor is called, the address of the new object is created, and that's the new object address. So somehow in the memory, constructor stores all three parameters to have basically rectangle ready to use. The same here, a new memory allocated for my second rectangle, instance variables initialized or properties are initialized, and again the same method is called, but now self is different. Self is a new address. Obviously R1 and R2 objects, they have different addresses in the memory. So all the objects basically share the same behavior, the same methods, but they have different data, and that's why when we call any method, it has to know what exactly the address of the object I'm dealing with. And that's a self. Self is the address of the object I'm working with. Okay, good. So two rectangles instantiated. Now I want to see the width and the height. I want to grow. And I want to see again the width and the height to make sure my grow method is working. And then I do the same with the second rectangle. Now you see how methods are called. What's the difference between a regular function and a method? We call a regular function just by name, but we call a method by first object, qualifier, then dot, and then only after the name of the method. What happens in line 7? Let's try to analyze. So if I'm trying to grow a rectangle, if I call this method, we're going to line 9. R1 is automatically copied to self, and we increment width and height for R1 for the concrete rectangle. So that's how basically we share all the methods. That's why all the methods are the same and they used on different objects, because anytime you call a method, the method knows which object to process. Self is the address of the current object. Okay, so let's run it. What I expect here is I expect here to see my old dimensions. Then I expect to see my R1 new dimensions. Then I expect to see R2 dimensions. And finally, R2 new dimensions. So let's run it. Let's make sure it's working. Yes, that's precisely. That's how you grow and that's how you shrink. And today it was super important lesson because we discussed basically terminology, the most important terms about classes and objects, what OOP is about. So next lessons we are going to contemplate, we are going to talk about details, but right now your task is just to understand what is a class, what is an object, what is a method, an instance variable or property, instantiation, and constructor initializer. So just try to get used to this terminology. Thank you very much for watching, and we are going to continue our lessons very soon. Be with us, please. Bye bye.